Welcome to lesson 1.3, percent of change. And let me tell you, percents do change. All one has to do is look around at the interest rates on mortgages to see the difference from just a few years ago. Percentage rates were very low. They were in the 2 and 3%, and now they're in 6 and 7% after just a few short years of a bad economy. So percent changes, and it changes on a regular basis. So we're going to talk about the percent of change of things. As things improve, sometimes it's about a process. As things decline, sometimes it's about attendance. Percents rise and fall, and so we're going to talk about that. Percents greater than 100% represent more than the whole amount. So when a percent of change is 150% or 200%, that means that your answer is going to be greater than it was the last time that it was calculated. So you need to be aware that percents can be greater than 100%. So let's look at example 1. Let's start with that. So in example 1, we want to express 1 out of 400 and 7 over 5 as percents. So we know how to convert percents or fractions to percents. So we just pull up our calculator and we say 1 divided by 400 for the first fraction, and we get 0.0025. Now to convert that to a percentage, we just move the decimal place back, or we multiply it by 100, which is the same thing. So that's going to be 0.25% for 1 out of 400. So let's do the same thing for 7 over 5. So 7 divided by 5 is equal to 1.4. We're going to multiply that times 100 to get our percent. So 140% is the same as 7 over 5. And there is a way that you can check it to make sure you did it the right way. Here is the way you check your percent to go back to the fraction. You just turn it back into the fraction. 140 over 100, and then you reduce. The first thing I see that we can reduce is we can take the zeros off the end. So that takes us to 14 over 10, which we know both of these are even numbers, so we can divide 14 and 10 by 2, which reduces to 7 over 5. So if you can get back to your original fraction by putting it over 100 and reducing it, then you know that you did the math correctly. So remember, what we do here is we divide the fraction and I'm going to use 7 over 5 as an example. So 7 divided by 5 was equal to 1.4. And then the step 2 is to multiply by 100 and add the percent sign. So that equaled 140%. All right, and those are the 2 steps that you need to remember and write down to get you from a fraction to a percent. This part gets you to your decimal. This part takes you from the decimal to the percentage. All right, let's look at example 2. So in example 2, it says the fee for traveler's checks is 1.5% of the face value. Find the fee for $3,500 in traveler's checks. So we're going to go back to our formula. Percent times the base is equal the number. And we have our percent, which is 1.5%. We're going to turn that percent into a decimal by dividing it by 100, which simply moves the decimal place 2 spaces. So our decimal is going to be 0.015, and our base is going to be the $3,500 in traveler's checks. So $3,500 goes in our base, and then that is going to tell us our fee, which is going to be our number. So all we do is multiply these two together. I'm going to pull up my calculator and say 0.015 times 3,500. And that gives us 52.5, which in currency would be $52.50 is the fee or the number that we're looking for the fee for the traveler's checks. Let's look at example 3. In example 3, Tom bought a rocking horse at a yard sale for $8. That is going to be his base. And he sold it online for $22. That is our number. The selling price was what percent of the cost? Because this is our cost that makes it our base. So we're going to say what percent. We're looking for the percent. So we're going to say P, because we don't know what the percent is. And our base is $8. That's what he bought it for. Now what he sold it for is going to be a greater percentage than 100 because this is a bigger number. So 22 goes here. So now we're going to take our 8 that we know and we're going to divide both sides by 8. And our percent is going to be, let's pull up our calculator, 22 divided by 8 is equal to 2.75. And we know to go from a decimal to a percentage, we multiply by 100. So times 100 is 275. So 275% is the percentage that he sold it for over his cost. So in order to find the percent of change, there are two things we need to know. The amount of change, which is going to be your N, and the original amount, which is going to be your B. Percent is frequently applied to change in value. This might happen, for instance, when the quantity of an item rises over a period of time, or when the price of an item is reduced for a sale. These changes are referred to as percent of increase or percent of decrease. So this N could be a bigger number or a smaller number than the base. And when this N is a bigger number, then we know it's a percent of increase. When N is a smaller number than our B, then we know that it is a percent of decrease. Let's say, for instance, if the price of an item rises from $75 and it goes to $90, we know that's an increase. To find the percent of increase, we would simply subtract. We would say 90 minus 75 is equal to 15. So the percent of change is not the amount here. This is the amount of change. So to find the percent of change, what we're going to do is use our same formula. P times B, percent times base, is equal to the number. So to find our percentage, we don't know the percentage, so P is our variable. The base is going to be 75 because that is what we started with. We started with 75 and we went to 90. And that amount of change, which is N, is 15. So now we can divide both sides by 75. And then that is going to be P is equal to, we'll use our calculator, 15 divided by 75 is equal to 0.2. To get our percent, we multiply times 100, and we get 20% is the percent of increase. So we were not looking for this 90 here. We were not looking for the total amount increase. We were looking for the percent of increase. So the percent that it increased was 20% because it increased $15. So there's a difference to finding what increase overall versus the part that is increased. And the part that is increased is the percent of increase or the percent of decrease. You have to find the difference between the two to know how to solve the problem. So in this case, we had an increase because 90 minus 75 was a positive 15. So if that would be a negative number, then that would definitely be a decrease. So rather than using the basic formula for percent, you can think of percent of change as the ratio or the amount of change over the original amount. So what that does, instead of P times B equals N, you can skip this whole step and go directly to P is equal to N over B. All right, so you can use this variation to show percent of increase or decrease. And that's a formula that needs to go on the back cover of your book. So then you don't have to do this part. You would just go straight to this fraction here, which would give you this amount, right? So that's what you want to do. You want to do as few steps as possible. So if you already know the formula for the amount of change or the percent of increase or decrease, that's what you want to go to. All right, let's move on to example 4. So here we have the price of $90 was reduced to $75. What is the percent of decrease? So this is the opposite of the problem I just showed you, or the example I just showed you. So now we're going to go from 90 to 75. So we're going to have an amount of decrease here. So 90 minus 75 is still $15, right? We're going to go ahead and use the percent of increase and decrease formula. So that is going to be the amount of change, which is N, over the base, which is B. So the question then becomes, which number do we use as our base? You'll use the original number as your base. So in this case, we're going to use 90. So the percent is equal to the amount of change, which is 15, over 90, because it reduced, it didn't go up. So we're going to use the amount that it was reduced from, which is our base. So when we divide 15 by 90, we're going to get 15 divided by 90 is 0.166666. This is going to repeat forever and ever and ever. And this 7 is actually not a 7. It's just the calculator has run out of spaces, so it's rounded everything else up to a 7. So what we can do is we can just say 0.16 with a repeater. 0.16, and this is that line above the 6 tells us that it's going to repeat indefinitely. So we are just going to round that. When we multiply it times 100, go ahead and take your number that's in the calculator and multiply it times 100 to get your percent. And then we're just going to round it to 1 decimal place. So we would round this number to 7. So our percent is actually going to be 16.7%. And that's what we're going to do throughout the book. Whenever we have a percent like this that repeats, you can write it like this, but just leave it in your calculator and go ahead and multiply it by 100 and then round to 1 decimal place. And that's going to give you the answer that you need. So 16.7%. Notice that the percent decrease from 90 to 75 was different from the increase of 75 to 90, because the percent increase is based on 75 and the percent decrease was based on 90. So the percent is different. It's not going to be the same percentage, even though we had the same amount of change. So let's look at example 5. In example 5, in an undefeated season, a football team saw their season attendance increase from 10,000 fans the previous year, so that's our base, that's our B, to 25,000 fans the next year. So this is our new amount, right? What percent did the attendance increase? So we're looking for the percent of increase. So we need to find the amount of change. So 25,000 minus 10,000 is equal to 15,000. This is how much it changed. So we're going to use the formula percent is equal to the amount of change over the base. So when we sub those numbers in, the amount of change is 15,000 and the amount of the original amount, the base, was 10,000. So we're going to just divide those numbers. Let me clear this. Divide 15,000 by 10,000. And that equals 1.5. We're going to multiply that by 100 to get our percent. And that's going to be 150%. Oops, I forgot my zero. So 150% is the amount of change in their fans from one year to the next. Now let me show you a little trick so that you don't always have to use the calculator to reduce. You can reduce your fractions like this. Get rid of your zeros. We divided by 10, we divided by 10, we divided by 10. So 15 over 10, we can reduce that to, we know this is divisible by 5 and this is divisible by 5. So P is equal to 3 over 2. We can reduce that mentally. We can see that that's 1.5. So that's 1.5. And then when we move our decimal place 2 places, we know that's 150%. Because we move it 2 spaces right back there. So we have to add a 0 to get it there, right? So you don't necessarily have to use the calculator when you have large numbers. Learn how to see how to reduce things and just deal with your most reduced fraction. And that's going to save you some time because it does take time to pull out the calculator, type the numbers in. When you can have it in smaller numbers, it's just easier to work with. So you can get to the same percent by reducing your fraction first and not depending on the calculator all the time. If you depend on the calculator all the time, your brain gets lazy. And you know, it's good to use it for numbers that are really big that you can't reduce, that you can't solve, like odd numbers or weird numbers. But when you have a number like this that you can easily just knock it down to 3 over 2, use your brain as much as possible. Studies show that the longer you use your brain to do little stuff like this, that the less likely you are to have early onset dementia or brain fog as you become older. So continue to use your brain for little mental math problems as much as possible. It doesn't mean you have to do the whole problem in your head. It just means do it on paper. And figure it out in your head as you do it on paper. I don't expect you to be able to do all of this and hold all of this in your short-term memory as you're working the problem, but you can definitely see the little tricks. Okay, I just need to do this, and I can reduce that to 3 over 2, and then I can mentally calculate, multiply that by 100 and calculate 150%. Those little things that you do along the way without having to pull out a calculator each time, it's going to keep you sharper longer. And if you care about your mental health at all, especially as you age, you're going to want to start doing this now and make it a habit. If you make it a habit to do these things without a calculator now, then it will be better for you in the long run. So I highly recommend using your brain as much as possible. So let's look at the next example problem. So in example 6, it says the planners for a community event expect a decrease of 30% from the previous year when 5,600 attended. How many people do they expect this year? So this year we are given, or in this problem, we're given the percent of decrease. So we can, and our base. So we can do a straight multiplication to find our answer. But first we have to figure out how many they expect for this year. So if they expect a decrease of 30%, 100% of the amount last year, which was 5,600, minus 30%, they only expect 70% of the people to show up. So that is the decimal that we're going to use. We're going to turn this into a decimal. That'd be 0.7. This is our percent, and we're going to use the P times the B is equal to the N for this problem because we were given the percent and the base and not the number. So it matters what you are given as to which formula you use. So we're going to multiply this times the base of 5,600 people. That's how many was there last year. We're going to get 70% of 5,600, and that is going to tell us the number that they expect to attend this year. So all we do is we open our calculator and we say 0.7 times 5,600 is equal to 3,920. So they expect 3,920 people to attend this year. This is something that you do, this is a number that I use when I work with Vacation Bible School, is we look at percentage of growth in regards to population of the city, and we apply that to the number of children who attended VBS last year. When there is no growth, we expect to have the same amount of children who attend, and when there is growth, then we apply that growth to the amount that we had last year, and then we plan for that many students or that many children to show up at VBS. So that is definitely a number that you will use in everyday life. If you do any kind of event planning whatsoever, you do need to look at population trends and responses, like even if it's just like an RSVP thing that happens, you want to look at the percentage of RSVPs that you get versus the percentage of people that actually show up, because a lot of people don't RSVP. So this is something that you can use in everyday life. And that is the last example problem that we had for lesson 1.3, percent of change. So I will see you in lesson 1.4.